glad I remembered to start the recording. Fantastic. So yeah, I would encourage you to paste these into Eclipse if you are able to do so, although I know that copy pasting from PDF can be a little tricky. Let's see. No, it looks like it worked. It just didn't, yeah. It put it all on one line for some reason, but it did work. That's cool. And then I'll paste the other one in here as well. I don't know why it decides to paste it like that, but it's not that big of a deal. It's not that hard to fix. Okay. Cool. So we now need to figure out what's going to happen when we plug in these variables to these methods and ask it to execute. So obviously on an exam you're going to have to track these out on a sheet of paper, but you're really just sort of replicating what the debugger is doing. I hope you kind of understand that that's actually what you're doing on these code reading problems. You're playing the part of the debugger. So the best way to study for these code reading problems, I think, is to, yes, work them out yourself on paper if you want to kind of challenge yourself, but if you ever get stuck, then walk through the debugger. See what the values of these variables are at every single step. I can plop this right into the main method and then watch what happens as it executes. I can either, you know, skip directly to the answer, or I think it's probably a little bit more useful to obviously walk through step by step and see what the code is going to do. Oh, this one didn't paste properly. There we go. And the interesting stuff starts here when we have our first call to B. So I'm going to set a breakpoint there, and let's see what happens. All right, I am now in debug mode. I've paused on line 18, and nothing's gotten printed yet. The only thing that's happened so far is we've created this variable called y, and we're about to set this variable m to be the result of this method call, but we have to go do the stuff in that method first. So let's step into B and see what's going to happen. First thing we're going to do is we're going to print out just a little indicator that I'm in B. We're going to add 1 to y and then give it back. Well, that's pretty straightforward. So y was 3, it's now going to be 4, and so our value of m therefore will be 4, and then I'm going to print out 4 followed by 3. So here then is the final answer for that problem. I imagine some of the other ones are going to get, well, yeah. Oh, and then they give you some more and ask you to do kind of the same idea. So for C and D, you can see that they're calling A and B. So it's not going to be as simple as just jumping to B and then coming right back, right? It could be jumping to B, or jumping to C and then jumping to A and then back to C and then back to B. In fact, I could probably even show you that in the debugger as well. It'd be useful to get familiar with exactly how these methods are executing, since that's essentially what these problems are asking you to show. Oh, almost. Okay, there we go. And then D. Probably going to paste this one weird too, huh? A and B pasted pretty well, but C and D did not. That's interesting. I don't know why. Okay. I believe I have fixed the problems. Return. Oh. There we go. Okay. So now if we want to take a peek at D of 1, for example. I know I skipped one, but let's try this one out. I'll set my breakpoint here on line 27 and start it over again. So we're going to jump to D first. which tells us to print out the letter D. But then D says, okay, now jump to C. So the next place that I'm going to end up is in C. And then C says, okay, print out the letter C, but then jump to A. So I'm going to jump to A. All right. A is finally not going to tell us to jump anywhere, but what we're actually doing here, you can see, since I'm in the debugger, I'm sort of replicating what I'm seeing on the call stack, except just in reverse. So here I see DCA, and here I'm saying DCA. So each of these methods, by printing out first thing, I'm really just replicating the call stack, right? Before I do any arithmetic. So here I'm going to get the value of 4 back for x, 1 plus 4. That'll be set to this variable w. But okay, now we need to jump to b and do that. So there's my b. That's going to give me back 2. So 4 plus 2 gives me the 6. Then I'm going to return from c, which gets printed out. There's my 6. W times 5 is just 5. You can see that nothing happened to W along the way here, right? W just passes through untouched. So regardless of what happens, regardless of what you did for these two lines, you should still be able to see that W is going to be 5, and then we'll just print out that 5 at the very end. There is our answer. For these code reading problems, it's absolutely crucial to understand this idea that when you call a method, it says go to D, and then when D is finished, it's going to go back to the same place where the method was originally called. That is one of the trickier parts of understanding how methods work. Usually what I see people get tripped up on the most. Any other questions on this one? What's next then? Who's got another problem? Yeah, in the white shirt. Sure. Okay. Yeah, I know these problems. So for problem number 8, this is, I think, the easier one of the two to understand. We're basically tasked with drawing a dashed line. So a dashed line that goes from the bottom of the window to the top. So we're given the x-coordinate at which we want to draw the dashed line, and then it's up to us to draw the dashes going from bottom to top. They gave us some constraints here. So each dash is 0.02 long, and each space in between the dash is the same, 0.02. In fact, I think that piece of information, those two pieces of information are important. In fact, the biggest thing I think to keep in mind for this problem is that we should treat those as one cycle. The dash and the empty space should be treated as one unit, right? One cycle, in order for me to make a dash that's, a line followed by a space. So with that in mind, I can actually view this dash line not as a series of repeated dashes, but a series of repeated dash spaces, if that makes sense. That's the repetition. That's the block of repetition that's happening here. I suppose you could approach it the other way as well. But ultimately what I'm trying to get at is the distance between the start of this dash and the start of this dash is 0.04, right? 0.04. So with that in mind, we can come back over to Eclipse and start trying to write some code. I'm going to make a new file for this one. Okay. So I know that I want my y value to start at the bottom, which is 0, and then go all the way up to the top, which is 1. And so, this might feel a little bit weird to do, but we're used to having integers here, but there's nothing that says we have to use an integer. We can use a double here. Y is going to be less than 1. And then I want y to go up by 0.04. 4 every time, right? Since that's how much space there is in between the beginning of each dash. That's how big a cycle is. And we're actually almost done. The instructions tell you about the standard draw.line method that's available for you to use. And so that's what needs to go inside of this loop here. The x values are easy. You were told what the x value should be. It's just whatever value is being fed into you as a parameter. For the y values, we wrote this loop, right? So the beginning of the dash is just going to be wherever y is, and the end of the dash is going to be plus, oops, 0.02, halfway through. I think we're done. I think that's it. But we can test it out, certainly, and make sure that it works the way we would expect. So if I put a dashed line at x equals 0.5, that should just be right down the middle of the screen, right? Oh, I forgot I accidentally a word. Whoops. There we go, right down the middle of the screen. I can either change this number, or actually, if I wanted to, I could actually just drop another dashed line in at 0.25, and they should have 2 of them. Yeah, looks good. So I'm pretty confident that this one is gonna do the trick for me. Any questions on this problem before I move to the next one? Okay, so the next problem, I think, I understand why you asked me about this problem. I think that, part of why it's so complicated is just the wordiness and the story and everything. Basically, the idea is that I'm going to start over here at the left-hand side of the window, and the paradox, Zeno's paradox, goes something like this. It says, I'm running a race, and the way I'm going to get to the finish line, which is all the way over here, is to just cut the distance in half between me and the finish line every single time that I move. So I start here, and I want to go all the way to the right, so the first time I'm going to cut the distance in half. The second time I'm going to cut that distance in half, and I'll cut that distance in half. And I'll keep repeating that. And the paradox, right, Zeno's paradox is that while this might seem like a good idea at first, he'll never get to the finish line. It'll just I'll be able to infinitely split that distance in half, right, forever, and I'll keep getting closer and closer and closer to the finish line, but I'll never actually get there. Okay, it's a neat little story. It's a fun little story, but the lore isn't super important to this problem, right? The problem is, how do I, draw a line here and then compute where I need to go next? So if I start here, I need to compute half the distance and then go there next. If I'm here in the middle of this, then I need to compute half the distance and then go there. Compute half the distance and then go there. And then, of course, we have to do all of this recursively. That's the other expectation that's part of this problem. We try to help you out here by asking you to identify the recursive substructure. So the recursive substructure, remember from prep work, the prep example that I used was the example of factorial. So we started with a simple example, understanding the idea that saying 5 factorial is equal to 5 times 4 factorial, right? And I have now stated the problem in terms of itself. I've defined factorial in terms of factorial. That is recursion. We really wish to generalize this though, so we eventually landed on, the factorial of n is equal to n times the factorial of n minus 1. And that is ultimately what our code became, right? So starting with that simple concrete example of factorial of 5, once we were able to generalize that, we were able to determine the recursive step. Well, here we're starting with this entire picture, and if I look at just the right half of the screen, I can see that it's just a smaller version of the picture of a whole. And if I look at the quarter, that's also just a smaller version of the next step. Or another way to think about it is the recursive step here is to draw a line where I'm at, and then recursively move to the next position. The base case then where the dashed line gets drawn, is somewhat arbitrary. So the dashed line gets drawn when we get, close to the right-hand edge of the screen. Remember, we'll never actually get all the way to the right-hand side of the screen. So we're just going to stop whenever we get some arbitrary value close to the right-hand side of the screen. So let's go ahead and sketch it out. The code is actually, there's not a lot of code, right? The tricky part, I think, is understanding the recursion here. So the double X that's being given to us, that's our current position. We need to draw a line at that position. If I am at my base case, I want that to be a dotted line. Most people typically start with the base case. So I want to stop the recursion when X is very close to the right-hand side. And, what is your definition of very close? I don't know. The right-hand side is 1, so I'm not picky about this number, right? Something reasonable there is absolutely fine. This is my base case. I might even mark it as such. Okay. So if I'm here, I need to draw a dashed line in my current spot. We have a method to do that. We worked on that in the previous problem. So that's it. This is my base case. Just draw a dashed line and I'm done. For the not base case, for the recursive step, we need to draw a solid line at our position. So I'm going to use standard draw dot line to perform that action, where our y values are going to be just going from 0 to 1, right? From the bottom all the way up to the top. And now we need to do some recursion. We need to figure out where I'm going to go next. So if I started at 0, I need to be at 0.5 next. I'm going to break this down into a few small pieces. Some people just write this all out in one line, and that's fine too. I don't have a problem with that. But I like to break this up just to make sure that the arithmetic is clear. So the distance left, the remaining distance for me to go, is equal to 1 minus my current position, right? Since 1 is the finish line. Okay. I want to move half of that. So the distance to travel is, the distance left divided by 2. I want to go half of that distance. And so then my next position is going to be my current position, which is x, plus the distance that I have to travel. And so actually my recursive call should just tell me to proceed to that next position. Again, I broke this up into pieces so you could clearly see every step of the arithmetic along the way. Did you need to do it that way? No, absolutely not. A lot of people would just do that all in one step. That's fine. I don't have an issue with that. I just want to make sure you understand what the math is and why I'm doing it that way. We should also give this a test run. If I say start at the left-hand side, Zeno of 0, I hope to get something that looks kind of like the picture from the exam. Hard to see the line on the left side of the screen because of the border of the window, but it is there. You might have to take my word for it. Here's the dashed line all the way at the very end, and you can, if you can tweak this depending on where you think the end should be. You'll see even just making that small change scooched it over a little bit, and but obviously there's a point where at some point it doesn't. You're not going to see the difference anymore. Right now it's just drawing lines on top of each other at the very far right hand side of the screen. Okay, that's probably a bit overkill. So something like this is completely reasonable. But let me pause here and see if anybody has any questions about this problem or how I approached it. Yeah. Yeah. Mm-hmm. Mm-hmm. So, I mean, I'm familiar with the problems you're referring to when you kind of like the circles problem from Studio, right? Similar along those. We usually try to give you a picture which you can use to do the math. Maybe we'll end up doing one of those later, I don't know. But I'm not super picky about the numbers. I understand that you can't see what your code is actually doing during the exam. So I'm more interested in the major pieces being there, the base case being there, and the recursive steps, plural. For those problems, there's usually more than one recursive call. So definitely looking for that in particular. If your numbers are off a little bit, that's not a major concern for me. Absolutely. Did you have one in mind? Does it matter? Were there any questions on this one before I do that one? Yeah. Oh yeah. I would just circle the right half of the picture. So I would just circle the right half of the image. That's what I would circle. The full image is the big problem, right? The next place that I'm going to after that is the right half of the side. So my argument is that the right half of this image is a smaller version of the full image, since it's just dividing the... Well, you don't want to skip a step, right? So if I'm starting here, the next step is here. It's not here. Does that make sense? All right. And you said fall 2019, number 8. It's one of the drawing ones. I'll know it when I see it. Here we go. Perfect. Boxy. I like this one. Yeah. Okay, so we've given you this little image here, and we want you to replicate this. So this is going to be recursive. We've shown you how to use the rectangle method. I think is there a square? I don't know if there's a square method or not, but honestly, it doesn't really matter. You've probably seen this before or similar before, so I would expect you to, have some idea about how to use this. And here's the original call. So I'm actually going to go ahead and set this one up. Boxy prop, whatever. Public static void boxy. So they gave us 3 doubles, and they specify so 0.5, that's the half, and then 0.25 would be the size. And because it's a square, they're using that 0.25 for both the half width and the half height. That's why there's only 1 value instead of 2, right? So it's going to be double x, double y, double width, or whatever. It doesn't really matter. Okay. Here, this one, this is your hint as to the base case, correct? But this is actually, so it's not that much different than the last drawing problem that we saw. When you're dealing with recursion and drawing stuff, the base case is almost always going to be based around, the drawings getting to be too small or too close together somehow, right? So in this particular case, the squares are shrinking, and eventually they're going to get to be so small that we can't even see them anymore. This is telling you that you can stop at, when the squares are smaller than 0.0199. Again, not super picky on the math here, just giving you a stopping point. More concerned about the fact that you recognize that this should become your base case. That is absolutely something that I hope you will be able to show me on the exam. So what we mean by that is something like this. If the width is, less than 0.2 or something like that, actually, if the width is less than 0.2, we're finished. You could argue that, what do I need to do here Nothing. You could leave this blank. That's actually allowed. And then, so what would that mean? If you left this blank, you would say else, and then this is where you do all your recursive stuff, right? That's okay. You could get it to work that way. I really do not like having an empty if statement. Don't like it. Even though you're allowed, even though the computer's not going to stop you from doing it, it's sloppy. And the reason why I think it's sloppy is because instead of having this big blank thing taking up extra space, I could always just come up here and flip the sign, right? So I could always just say, instead of doing it this way, I'm just going to say if the width is greater than 0.2, I'll do my recursion. Otherwise, nothing, right? So these are just two different ways of saying the same thing. I'm arguing that one's a little bit cleaner. You're allowed to disagree with me. I'm not going to take off points on the exam, by the way, for that either. Just expressing an opinion. Regardless of how you get there, we need to draw a square. Step one is draw the square. So standard draw dot rectangle. We have our x and y values. Oh, Eclipse is smart. It plugged in. That's perfect. That's what we want. Absolutely. Okay. We now need to figure out where we're going to go next. Except where we're going to go next is actually two places. I'm going down and to the left. I'm going down and to the right. So for each of those two paths, I need to figure out what is my x and y position for this path and what is my width. So for bottom left, I'll focus on that case first. You can see that the center point is actually on the corner of the bigger square. So I should be able to figure that out. That's going to be, x minus the width, and then y also minus the width, right? I'm moving negatively in both of those directions. So my next recursive call would be box C for x minus the width, and then y minus the width as well. The width itself, if I look at this, so I see this appears to be about 1/4. Well, let's think about this. It's the half width, right? Or the radius of the square is another way of thinking about it. So it's actually just being divided in half. The radius is being cut in half of the square. Again, not super picky about whether you got those numbers 100% exactly correct. What I'm more looking for is the appropriate recursive structure. And even though we're not done yet, I think we can already kind of test this to make sure that we're going on the right path, at least, by plugging in the original call and seeing what happens. I'm hoping that I at least get the half of it. Uh-oh. And I didn't. Whoops. Oh, it's like, I think my base case is too small, or too big, rather. Oh yeah, there we go. I have my base case far too, it said 0.2, that's very big. So I was not drawing these smaller squares. There we go, I'm going down and to the left. So I need a similar one that's going to go down and to the right. And so I'm actually going to copy this. And I just have to figure out, okay, y is still going down, but x is now going in the positive direction. So if I'm going down and to the right, I'm just going to add the width to x for the second one. And there we go. And you can argue, you can tweak the base case to get it exact. Again, on an exam, I am very much 100% aware that you do not have the ability to keep running and testing to get everything exactly right, so I'm not looking for you to get it exactly right. I am definitely looking to see that you've got the base case here, definitely looking to see that you're drawing the shapes, and then here, on this problem in particular, one of the most important things that I'm going to be looking for on these kinds of problems, this is an example of a divide and conquer problem. So we've seen multiple examples of these. We saw the circles one in studio. Max path length on the assignment is actually an example of a divide and conquer problem. I know everybody loves that one. This is another example of divide and conquer. I'm seeing the recursive pattern go off in multiple directions, right? That's my clue. I'm seeing this recursive pattern go off in multiple directions, down left and down right. And when that's the case, I expect to see one recursive call per direction that I'm moving in for these divide and conquer problems. So on max path length, which I realize some of you are still working on, the divide and conquer there is the fact that I have to look up, down, left, and right, so my recursive calls are going to be one going up, down, left, and right. So you just have to match your recursive calls to the problem that you're trying to solve. Some of the other ones on here have more than two, right? More than two paths, so I would expect to see more recursive calls to accommodate that. That's really the big thing that I'm looking for here. Any questions about how I got, so the code, you can see the code is not long. Code is not a lot. But conceptually, it's kind of deep. So any questions about this problem or any of these other problems that I can answer? Yeah. Sure, yeah, this is just the, from the exam, the starting point. This is right here. Yes? Like this piece? Yeah, so that's a great question. So we talked a lot about, so actually module 4, I know I said it was, graphics, standard draw, but actually the topic for module 4 was APIs. And so what I mean by APIs is the idea that I should be able to explain to you that there is a method and tell you the inputs to that method and the outputs to that method, and you should then be able to use it, even if you've never done so before, right? That is programming. That's what we asked you to do in Module 4 when we introduced standard draw. So have you used this method before? I expect you probably have at some point in time, but even if you haven't, right, I could actually give you a method from some other piece of code that you maybe have never even seen or used before. But as long as I give you this kind of information, here are the inputs and here's what it does, I would expect you to be able to use it. But to more directly answer your question, yes, I will give you this information. Absolutely. I'm not just going to expect you to use something, even if it's from standard draw and I've expected that you've used it before, I'm not going to expect you to have memorized how all that stuff works, right? That's not a good use of your brain space anyway. So I will give you that information. Yeah. Great question. Yes. Did you have another question on this problem, or are we going somewhere else? Sure.
So if you give us a method and use a programming questions, you kind of given that you have to use it explicitly in code. So when I was doing the practice exams, I was thinking, he wants us to use like that programming method because Boxy has 3 parameters and other side of the rectangle has 4. You don't have to use it explicitly, you just do it next to the draw project.
Sure. So that's an interesting question. I mean, absolutely, you could use a helper method here if you wanted to. I'm not going to stop you. My advice would be, if I put a method on here, you don't have to use it. I think I can't remember if a square method exists in standard draw or not. It may not, but it does. Yeah. So, if you decided to use square instead, okay, like whatever. I didn't write this problem. I'm not sure why they chose rectangle instead of square in the first. I don't know, but it doesn't matter to me. However, I do think it's important to understand that if I put this on here, I'm telling you that you can solve the problem with this, right? I'm telling you for a fact that there is a solution that can be achieved using this. So you can choose to ignore that and go a different route if you feel strongly about it, but that's sort of at your own risk, right? Yeah.
Will we use methods to know how to estimate on all of these machines that that?
Well, that's kind of what I was just explaining. You'll be given. Yes. For what you need. I'm not going to give you the whole thing if you don't need the whole thing. That would be a lot of paper, but I will give you the pieces that you need to solve the problems that are on the exam. Yeah. What other questions do we have? Yeah. Question 6. Okie dokie. This one here? Okay, happy to. So keep in mind for starters, right, this was true on the first exam as well. Anywhere you see ARGS processor, we've been using scanner for that. So that's just a name change more than anything. They do work slightly differently. But the bigger part of this problem is to recognize the fact that there's repetition going on here, right? There's a lot of repetition going on here. In fact, we've tried to very clearly show you the repetition. There's, you know, this chunk, there's this chunk, and there's this chunk. So very clearly three chunks of code being repeated. You're being asked to write one method that can be used to replace that repetition. That's what methods are used for. We have a name for this. It's called abstraction. When I see that I've got repetition in my code, I'm going to abstract that repetition out and create a method and then just use that method in its place. There are lots of reasons why we like to do this, but let's go ahead and see if we can't clean this one up a little bit. Oh, that pasted pretty nicely, actually. So let me see if I can just switch this out for scanner real quick. And then we can try and give this a go. Oh, that's annoying. Oh, shoot. I'd have to redo all of these print statements, too. Dang it. Well, I'm not going to redo all of that because I'm going to refactor this code anyway. So I'll fix it up as I go. I'm not going to swap all this out right now. Here's what I'd like for you to recognize. The fact that each of these three sections is doing the same thing with a few small modifications. One modification is the actual text that's being given here, right? The computation itself, though, is exactly the same. The variable name changes, but that doesn't really matter that the variable name changes. So what I want to do is make a method, and what we're really doing is taking a value in feet and converting it to meters. That's the general behavior that's being done here. Whether it's a height or a width or a depth, I would argue doesn't matter, right? As far as the conversion goes, I'm just converting something that is in feet to something that is in meters. So I have feet coming in, I want meters coming out. That's going to be a double for my return type. Feet to meters might be a name that you could choose, although it's ultimately up to you. And then I'll have the feet value coming in. From here, I can actually just go ahead and you'll notice you have there's a couple choices you can make here. I didn't write this problem. I don't know what the intended solution was necessarily, but I've seen two main approaches to this. One where these three lines are the ones that are moved down into the method, and then another solution where it's actually all four of these lines are moved down into the method. I'm actually fine with either one. But there are, implications to that choice that you have to make. If you're just going to move the three down, there are different decisions, different things that need to happen as opposed to if you try to move all four of those lines down into the method. Let's start with just moving these three down. And you can see that, okay, this is now going to be called feet, and I'll just call this, feet. Or I'll just call this meters now, right? Just do some variable renaming. This is just rounding, right? This is just rounding the values. So meters, 2 decimal places. Boom. Okay? How do I do this, though? That's the tricky part. I need to have a way of specifying this piece. Well, pull in a string. So this is the numeric value, and this is the name of that value, right? What dimension does it represent? And so then this statement down here becomes something like this. Does everybody see what I did there? I added this parameter and then I just stitched it in. And then finally I'd also have to return, actually I'm not sure that I would have to return anything here. You can see whether or not to include a return value is a little bit ambiguous. The way the problem's been given, I actually think you could do it either way. I don't actually know that you need one. My first instinct was to include a return type, but now that I've done this, I don't actually see any reason why that's strictly necessary. And so now that I have finished this, I can actually go back through and replace these with method calls, right? Where I need to type the name of the method, feet to meters, plug in the value that I wish to convert, as well as a name. And I'll just do that for all three of these. Okay, and I know that I haven't fixed up my scanner issues yet. I don't know that that's particularly important, actually, for the purposes of this problem. The more important thing is the idea that we've abstracted out a few lines of code and then called that method 3 times instead. That's absolutely what the problem was expecting you to do. If you decided to include the scanner stuff down here as well, you actually can do that. So one thing that you might decide to do, and you would have seen this perhaps on assignment 5, I'm not sure, you could include the scanner actually as a parameter as well, which allows you to pass the scanner around to the methods. You don't have to do it that way. You could keep it, keep the scanner in the main method and use it here and just use the method to do the actual numeric computations. Or you could pass the scanner in and do everything inside of the method. I personally, for the purposes of this exam, don't care. I would accept either one, be happy with either answer. So whatever makes the most sense to you is perfectly okay with me. This does have a name, by the way. So you absolutely could see the word refactoring appear at some point on the exam. That's the act of taking a piece of code and rewriting it such that it is more organized, easier to understand, but doesn't actually change the functionality, doesn't change how it works. Refactoring. We asked you to do that on assignment 5 as well. It's a very common task. In fact, I would argue that professional programmers spend more time looking at existing code and rewriting existing code than they do generating new code from scratch. Which may be a surprise to you, but that's absolutely true for many programming jobs. You're not generating new code as often as you are fixing existing stuff. Any other questions about this problem? Okay. Happy to keep the questions rolling. It looks like we still have a little more than half an hour left, so we can do a few more coding problems. If anybody's got another one they'd like for me to take a look at. Or it doesn't have to be a coding problem, it can be any problem. Yeah, go ahead.
Can you do fall 19, number 6?
Fall 19, number 6, absolutely. Okay, code reading again, awesome. I like these problems. So just like last time, while I understand you won't be able to do this on the exam, At the very least, I think it would be good to use Eclipse to check your answer, if nothing else, right? Challenge yourself to do it on paper first if you really want to give yourself some practice. But then use Eclipse to work through the answer. That's also very, 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 very good practice. So that's what I'm going to do here. Paste in my method. Fix the indentations. All right, that looks readable. The first thing that they ask us to do, oh, look at this. We've got this big old array. Actually, we use the same array for both problems. That's convenient. Okay. So just like before, I'm just going to set a breakpoint on the method and walk through step by step. Watch the variables as we go. Make sure we understand where we're going. There's actually only one method here, so there's not going to be a whole lot of jumping around so much, right? But let's give it a go. All right, here I am in my main method, about to start executing this select method. So here we go. I'm going to print out values at location, and you can see that the location was given is 1. Here's my array. Location given is 1. So the value at position 1 would be the t, right? So t is going to be my first printed letter. There it is. The next location we're going to go to is going to be 3 times 1, so that's 3 plus 1, which is 4. So now we're asking to see if it's an even or an odd number. It is in fact even, so we're going to divide it in half. So that gives us 2, and I can actually step through the debugger. Whoops, did I do it wrong? Did I do some math wrong? Oh, I'm sorry, I did the if statement wrong. The next value is 4. I see what I did. Next is 4. We're checking the current location. So the current location is still 1. My apologies. I interpreted that one incorrectly. So, all right, that's why we skipped the if statement. And instead, we're going to jump down here. And this is our base case. This is our base case. If the location is 1, then we're done. We're going to return values at 0, which is going to be the E. And that is, in fact, what gets printed out. Okay, so that was the easier of the two. Let's take a look at the trickier one. 4 and 4. So we're going to put 4 and 4 in here. And try again. All right, step 1 says, print out whatever letter we find at position 4. Okay, 0, 1, 2, 3, 4. There's the R. That's what we're going to see first. The next position is going to be 3 times 4, which is 12, plus 1, which is 13. So that's quite a big value. If the location is even, which it is, we're going to divide it in half. That's going to give me 2 for my next value. And then we're going to go ahead and, I'm sorry, yeah. So actually, when location is 2, this number doesn't matter. That's what my brain is finally connecting the dots on, right? When the location is even, I don't have to compute this because it's just going to replace it. Got it. If the location is odd, then this is my next value. If the location is even, then this is my next value. All right, that simplifies things for the future. So we got our R, and we're going to go to the next value. The array remains unchanged. Our next value is 2, and we're going to decrease the count by 1, so it's going to go down to 3. This is recursive, so here we are back up at the top. Our location is 2. We get 0, 1, 2. There's the I. Our location is even, So based on what we said, I expect to jump down here and have our location be 1. Our next location be 1. So we'll do values, 1, and count is going to go down again, and it's going to be 3. I'm sorry, it's going to be 2 next time because it's 3 now. And we're going to keep going. Print out the values at that location. Location 1 would be T. All right. 1 is odd. So the next value is going to be this computation here, which would be 4. But also remember that the location is equal to 1, which is our base case. So even though we computed this next value, we're not actually going to end up using it. Our recursion is over. We're going to return values at location -1, which is the E. It's still the E, right? But notice what happens. That E is going to get returned. And I'm going to work my way all the way back up through the method call stack here. So even though that one was over, I still have to finish these other methods. It says select returned E. Okay, so I'm going to keep returning that. This is also going to return E. Also returns E until we get back to the main method, and it will print out that E at the very end. So here is the answer to the second problem. Tried to give you a little indication that you were doing it properly. There are a couple tricky things going on here, right? So the base case actually has 2 conditions. There's 2 ways that this can stop. Either when the count hits 0 or when the location hits 1. That's okay. There's nothing saying that there only has to be 1 base case. There can be more than 1. Absolutely possible. And you should have seen some examples of that in Studio and Lab as well. So here's another one. For me, honestly, the arithmetic was the tricky part of this problem, not the recursion so much. Any questions on this problem? Alrighty. Then who's got another one for me? Any other problems you'd like to see? Or any other questions at all? How are y'all feeling about the substitution method? Is that feel okay? Yeah? What's up?
Are you, how specific, like, does the way that we write have to be? Like, when you, in the module review, wrote it out, like, line by line for factorial or for the sum, does ours have to be line by line?
For this, oh, for the substitution.
Just for, like, the logistics of writing it, like, can, on one of most of the exams, practice exams ask for it, but is it fine if it's just, like, f of 4 equals f of 2 divided by 2 equals f of 1 equals that, like, just...
So I'm not picky on the format. Yeah, if you are trying to save space or whatever, that's okay. But it is called the substitution method for a reason. So I need to see the things that I'm looking for. Obviously, are all of the method calls, right? Should be present, and then the substitution, and the actual substitution from the base case back to the original method call is where the substitution method gets its name. So I definitely expect to see that happening as well. Be sure to run through at least some of those on paper ahead of time. Yeah. Yeah. Yeah, absolutely. I'd be happy to. I think it's, yeah. This is a good one, actually, to do. So, yeah, let's do this one. Can I get just, there we go. Stop this. Oh, I've got a lot of stuff here, huh? Sorry, give me just a second. Close all these programs. Okay. And we're gonna do substitution. Great. So here's the method that we're asking you to take a peek at. And for the actual substitution method, there's no, it's not code, right? I'm just going to do it all in comments, although we might play around with a little bit code for this problem later on. We're really just walking through the execution step by step and writing out all of the method calls along the way. So k is going to be set to 4 the first time through, and we're just going to check, all right, 4 is not greater than 25, so we're going to jump down here, and that's going to be equal to, let me spell this out. Fun of 4 is going to be equal to fun of 4 times 2, which is 8, minus 1, which is 7, plus 1, right? But now I have to figure out what fun of 7 is. Okay, fun of 7. 7 is still not greater than 25, correct? So 7 times 2 is 14, minus 1 is 13, so plus 1. All right, so we plug in 13, still not greater than 25. 13 times 2 is 26, minus 1, that is 25. Okay, 25 is not greater than 25, right? So we actually have to do this one more time here. 25 times 2 is 50, minus 1 is 49. All right. We have now hit the base case. For this particular example, 49 is greater than 25. So the answer that we wish to return in this case is 49, right? It just says this is 49. That's what this answer is. There's no more recursive calls, but we're actually not done. So if you stopped here, you would definitely lose some points. You are not done yet. We actually have to perform the substitutions. Now that I know that this is equal to 49, I'm going to substitute 49 in for the prior step. So fun of 25 is equal to 49 plus 1, which is equal to 50. And now that I know what this value is, I'll keep substituting all the way back up, right? It's equal to 50, and you can probably see where this is going. The arithmetic here is not particularly complicated. However, this is in fact what the substitution method tells us to do. And since this is where we started, that is going to be our ultimate result. I want to really be clear though that when I ask you to do the substitution method, the result, while not completely worthless, is actually probably the least important thing that I care about in terms of showing me that you understand recursion, right? So the way that these problems are graded, while yes, you will get some points for getting this number proper at the end, what I'm really looking for is that you understand the recursive execution of this problem. And what that means is that, even if you flub the arithmetic a little bit, I don't care as long as you show me the recursive execution is working well, right? The other thing too, just to really drive this point home, is the idea that what I've written down for the substitution method is exactly what you would expect to see by walking through this in the debugger. So if I come down here and just say, all right, do the thing, and step through the debugger as it goes, we'll actually be able to see all of the method calls take place, as well as the substitutions. So here I see k is equal to 4. I'm now going to see, all right, I've hit the case where k is equal to 7. Still haven't hit the base case. K is equal to 13, just like I thought. Still haven't hit the base case. K is now 25 and 49, and there's our base case, right? And take a look over here on the call stack. You can see I've got all of these calls to this method. In fact, if I start down here at the bottom, there's function of 4, there's function of 7, right? There's function of 13 in the exact same order that I expect them to appear. So really the substitution method is just like the code reading problems, it's another example of you just pretending you're the debugger, right? Walking through this step by step. And then the fact that I've hit the base case now, or that I'm at the base case, if I look at what happens after this, right, I see this shrink now. So the version where k is 49 is done. The answer to that was 49. That gets plugged in here. So there's the 49 from the past one. I'm going to add 1 to that. And so the next time I see, all right, there's 50. That one gave me back 50. So I'm going to add 1 to that. There's 51, 52. Finally, when I get all the way back here, you can see that the last value was 53. That's my answer. So the substitution method is really just showing the exact execution of the recursion as you would step through it in the debugger. And if you're having trouble understanding those problems, I would very much encourage you to do what I just did till you get it. Yes?
Can you give in the starting with
Yes. Right there. Any other questions on this problem? Yeah, don't forget to skip this part. I know this part seems like it can be trivial, or perhaps even unnecessary, but I will be looking for the substitutions. All right, we got about 15 minutes left. I can probably do one more coding problem in that time, if anybody has one they would like for me to do. If not, I'm happy to just call it and stick around and answer, just deal with you all individually if you have any other loose ends that you want to tie up regarding the exam or the homework assignment, or if you have anything you need to demo or get submitted, I'm happy to, I can even do that for you as well. Also happy to do more coding problems if anybody thinks of one. But, I'm here and I'm not going anywhere. I actually have another session starting at 2:30 as well, so if you want to stick around. Did you have a question in the back? Yes, be happy to. Let's do it. This will probably be the last one since we are running a little short on time. This is kind of a tricky one too. You've picked out what I consider, I don't know if I would consider this to be the trickiest, but it's definitely one on the trickier side of the problems that appear on these practice exams. It's important to understand for this problem that these arrays, you can assume these arrays are sorted when they're first given to you. So you don't have to sort them. That's not what we're asking you to do. I know we've asked you to do that before, but that's not what we're asking you to do now. We're asking you to take two arrays and then merge them together into this array. So I think the idea here is that I have to keep track of my position in each one of these arrays. I'm going to start by looking at the first value in each one, right? And I'm going to say, all right, which of these values is smaller, the 1 or the 2? And obviously the 1 is smaller, so I'll copy that over into my results, to my new array. And then because I've already used this one, I don't want to use it again, so I need to somehow indicate that, all right, I'm looking at the 3 next time, right? So the next thing that I'm comparing is between the 2 and the 3. And I say, all right, which one of these is smaller? So I'm always looking at one value from both arrays, right? Look at the value from A compared to the value from B. Whichever one of those is smaller, I'm going to copy that over. But I have to remember my position. I have to remember where I'm at inside of each of those arrays. So that's, I think, one of the important things to keep in mind for this particular problem. But let's go ahead and start coding it up. All right. The first thing actually that they ask you to do is to define the signature. So they actually didn't even give you the full method definition, right? They left some blanks there for you to figure out. But these two words are always going to be there, at least for this exam. That won't be true for the next exam. But for this exam, those two words are always going to be there. The next one is the return type. And for this problem, we actually showed you what the return type is right here. Right? I'm taking the value from the method and sticking it into this variable, and the type of that variable is an integer array. So that's my return type. I'm telling you directly that the return type is an integer array. And actually the same thing is true for the parameters. I can see there are two parameters here, A and B, and up here I can see that the types for A and B are also given as integer arrays. So that's what the types of the parameters should be as well. All right. So I need to make this array my result array. I think most people can see that the size of this one is just going to be the size of A plus the size of B. So we should know how to do that. That's not a tricky thing for us to do. A.length plus B.length. The tricky part for this problem is the idea that we have to keep track of our position in each of these arrays. I would say that we need to have a pointer into these arrays, remembering where we're at, or an index, remembering where we're at in each of these arrays. And so I would go so far as to say that you need variables for these. So the A index, I'm going to start at 0, and the B index, I'm going to start at 0, which makes sense. When I first begin, I'm going to look at the very first value from both of those arrays. I know that the smallest value is one of those two, right? So I'll figure out whichever one is the smaller one, and that becomes the first value in my result. So let's go ahead and see if we can say that, right? Or actually, we need a loop first. How many repetitions? What array am I looping over? Arrays. This is another slightly tricky piece. Might be tempting to iterate over one of these arrays, but I think actually we need to iterate over this one, right? Every time I go through the loop, I'm saying, all right, give me the next smallest value so I can plug it in here. So how many times am I going to do that? I'm going to do that once for each position in my result array. So we'll code up a pretty standard loop to go through this result array, and then we'll do what I was just talking about. If the value from the A array is less than the value from the B array, I forgot to declare types for these, didn't I? That would help, wouldn't it? If the value from the A array is less than the value from the B array, then that's what I want to go inside of my result array. Otherwise, I want the results to come from my B array. But we have to be a little bit careful, because after I have used that value, I'm going to bump the index up one, so that the next time around, right, when I'm comparing, I'm not going to reuse that value. Does that make sense? Why I increase the index variables by 1 inside of that if statement? So this is actually a pretty good start, and you would get the majority of the credit for this problem if you gave me this or something that looked very similar to this. But unfortunately, the problem is not quite that straightforward. That's, this is one of the reasons why I mentioned that this was a bit trickier, and let me show you why by trying to run the example that you were given. Okay, so if I try to merge these two arrays, I'm hoping that I get the answer that was shown in the textbook, but instead what I get, or not the textbook, on the exam, instead what I get is an error. I get an array index out of bounds exception, which is kind of a bummer. It tells me the index 4 is out of bounds for length 4. It even tells me what line it appears on right here. Right? And if we think about that for a second, index 4 is out of bounds for length 4. Well, that must be this array. This array has a length of 4, right? So think about what that means. I've gone off the edge of this one, or I've consumed all of them, right? Or in other words, the remaining values in B are all bigger than the ones in A. I've consumed all of these values. So when I try to perform this comparison, I'm saying, is the value in A less than the value from B? Well, there is no more values in A, right? I've used them all, and I've gone off the end of that array. Which makes this comparison no longer necessary, right? I don't need to check to see if anything is less than anything. I just need to use the values from B, because those are the only ones that I have left. So how do we fix that? We fix that by making sure that our index is less than the size of the array before we try to use it. Right? Make sure that the index is actually in bounds before trying to plug it in. Does that make sense? I hope. And so if I try to run this now, you'll see the error message is gone. It doesn't print anything. I didn't tell it to print anything. So the fact that it's not printing anything is not a concern. However, unfortunately, still not done. Still doesn't work. Because consider that this example, I'm trying to merge A and B. I would hope that if I came down here and tried to merge B with A, that it would also work and in fact give me the exact same answer, right? That's what I would assume to be the case. But if I do that, we'll see that, uh-oh, I got my error again. Think about it for a second, right? We took care of the case where we run out of values from A, but we still have values in B. Well, by switching them, I've now just passed the buck, right? I've moved the problem over. I've now run out of values in B, even though I still have values left in A. So I have to check for that as well. Unfortunately, that kind of makes things a little bit clunky. I have to actually add another condition up here to make sure that the B index is within range. Right? And you might be thinking to yourself, all right, we've done it. Nope, unfortunately, still not quite there yet. There's three situations that we need to account for. The case where A runs out of values, the case where B runs out of values, and the case where none of them have run out of values, right? So if none of them have run out, both of the indexes are in bounds, then I'm going to do this. That makes, and if if B is greater than A, then I'll do this. That's fine. If A is out of values, then I won't do this, and I'll do this, right? If B is out of values, then this will be false, so I won't do this, and I'll do this. But wait a second. I just said that B is out of values, right? So actually, I need a third condition here. Wherein I do this again. Whoops. I thought I copied both of those lines. And I'm making the argument that this is now going to do the trick. It ended up being, I think, a bit more complicated than I intended when I wrote this problem out. I was hoping for something more along the lines like the first thing that I showed you, and in fact did end up giving people the vast majority of the credit if they gave me at least that much. But for completeness sake, I hope you do understand that, if you were actually asked to do this, you would have to take these things into account. So I hope you understand that. This is also certainly not the only way to solve this problem. I have seen other solutions. It's hard to get one that is fairly concise, which kind of bothers me. I wish that I had a shorter solution than this, because this one feels a bit big and cumbersome to me. But it works, and that's what matters, at least for the exam. So I'll take it. All right, if you have any more questions, we're out of time. I don't have time to do any more coding problems right now, but I am going to do one more round at 2:30 if you want to stick around for that one if you have time. Or if you have some quick questions that you want to come up and ask in between, happy to help you out. Otherwise, I'll see you on Thursday, or perhaps in my office if you have questions between now and then. Have a good rest of your week, okay? Thank you.